Alright, so we're going to go into this a little bit and talk about the different VSEPR shapes we had discussed yesterday. There's 5, and this presentation has 2 different kinds of bent molecules. There's a lot more than just these, but these are the basic shapes. I'm not going to talk about that. So VSEPR, this is very intimidating looking, right? What are all these letters? But if you break it down, valence shell electrons. So those 3 words right there, that just means your outermost electrons, your valence electrons. So your outer electrons in the pairs, which is either going to be a lone pair or a bond, are going to repel each other. Outer electrons repel each other. That's all this giant acronym means. So no worries, and that's going to give you shapes because they're going to try to get away from each other. This is making it sound really like intimidating, this next slide. But basically, it talks about charge clouds. Those charge clouds, we had called those electron domains. And I like to call them areas of electron density. It's all the same. It's either a bond, so any kind of bond, or a lone pair. And so a bond or a lone pair is this electron cloud, this electron domain. Okay, and that yesterday before we had done the POGL, I drew like a bond up here, and I was like, how many things do you have going on around the central atom? And so if you remember with like carbon dioxide, it has 2 domains or 2 electron clouds, whatever, right? And then something like methane, with 4 hydrogens, it has 4. That's all this is talking about. So don't let that scare you. It's not anything really different than I told you yesterday. It's just a lot of words, and it makes it sound very intimidating. So you're going to predict the shapes, and we have 6 shapes. This is your linear, your carbon dioxide. Now, as far as y'all are concerned in this class, it's very tempting to look at a lot of these and go, oh, that's linear because it's in a straight line, even though you draw it and it might have some lone pairs. So as far as y'all are concerned, let me tell you something. If there is any lone pairs in that central atom, it's not going to be linear. There's a couple cases with the more advanced shapes that's a thing. But as far as, and here goes, this is linear. Now, if y'all had something like oxygen gas, and y'all had drawn the Lewis structure for oxygen gas, notice how I'm drawing the lone pairs as far away from each other as possible. But if you have something like oxygen gas, this is also linear. You know, that's not on your quiz tomorrow, but just something to think about. There's several different kinds of linear molecules. But for us in here, if you, it's just going to be those, that central atom is going to have this double bond. And so if you see a lone pair, you have to think about that lone pair kind of pushing, it will push these down. And so on your do now, the H2S, that's not linear. So this is linear. The bond angle is 180 degrees. These bond angles, at the end of your quiz, like I'll get you to draw the Lewis structure. You have to tell me the shape. And then for like an extra point, you can tell me the angle. Like, why don't you just get 1 extra point tomorrow? Why don't you just remember a straight line is 180 degrees, right? So there you go. That's no problem. Moving on to the next one. We had talked about boron and how boron was an exception to the octet rule. It doesn't have a lone pair. And so when I'm looking at this one, boron, trifluoride, it has no lone pair. And so what's going to end up happening, those electron clouds are going to kind of form this triangular shape. Sometimes you'll see this, I want to say it's with nitrate. Feel like I should probably draw it, but let's pick an atom. Maybe it's nitrogen, and maybe nitrogen's bonded to some things, and it has a double bond, a single bond, and another single bond. See how it doesn't have a lone pair? There's only 3 things. Like a double bond doesn't count any extra or different. This is going to be a trigonal planar just like this is. So you're going to do some practice here, and you'll see this. You'll have to fulfill the octet on the central atom by moving a lone pair, making a double one. This ain't any different than that. Same thing, okay? That electron cloud or electron domain, double bond, single bond, triple bond, it's all the same. Doesn't matter. They're all going to repel each other similarly. It's those lone pairs you have to watch out for. So this is trigonal planar, and when we had built this yesterday, it makes this triangular shape, and it is flat, and plane means it's a flat area. So if y'all look at your molecules that you built, you should just have this nice little flat 3 atoms on the terminal side. So no problems there. And it doesn't matter, like again, one more time, this could be a double bond and this could be a single and a single. This one is bent, and let me tell you why this one's bent. This is one bond, this is another bond, and this lone pair will push those apart. And so this is a bent shape. This is very similar to how we had looked at water yesterday, but water had 2 lone pairs. And so that's the only difference. It's still bent. I don't like the fact that this says 120 because that's not right. Do you know why that's not right?
Because the lone pairs take up more space.
Right, and so it's really like, for example, ozone's bent, and ozone has bond angle of like 116.7 or something. It's right at 117. And so when you have a lone pair, it's going to take up more room than that single bond. So like normally you'd have a bond here, and if there was 3 bonds, 120 degrees, you split it 3 ways. But this is wrong, and I don't like that. So it should be a little less than 120. Just fun facts with Miss Freeman. So this is our friend tetrahedral. No problems, 4 bonds, no lone pairs. So 109.5 degrees. So anytime you have a central atom and 4 bonds around it, that's tetrahedral. And 109.5 is the bond angle. That part right here will be optional. This part is not. Now notice here I have 3 bonds and I have a lone pair. So now we would expect that 109 degrees to be smaller because these are going to be shoved together more. So if you look at your model for yesterday, this should look tetrahedral and it should have a marshmallow on top. And so this is my ammonia, which in this case, if we just look at these 3 bottom atoms, it makes a little pyramid. You don't name it with the lone pair. So this is trigonal, has 3 sides, pyramidal. And so you can imagine tomorrow when you're taking your quiz, if you know this is 3 atoms on a central atom and a lone pair, it's trigonal. You see it? Pyramidal, because it's a pyramid. So these little models can help you while you're taking your quiz if you need them. And what ends up happening, we don't spend a lot of time on this in this class, but what ends up happening is, you know, you do some practice with them, and these shapes, you can start seeing them in your mind. And sometimes that's harder for people than others, and that's okay. So anyway, that's the marshmallow, and there's my 3 atoms, and it is trigonal pyramidal. Now, there's not a word bank on this quiz, so you need to learn those words, tetrahedral, trigonal, pyramidal, and some people say trigonal pyramidal. I told you that yesterday, but... and there's the bond angle. I think the little computer thing I put up had 107.8. If you want to memorize this, just go 107. I'm okay with just 107. Even on the AP exam, they'll give you wiggle room. For example, like water with bent, they'll say anything from it's supposed to be 104.5. They'll be like anything from 100 to 110 is acceptable. So, like certainly tomorrow on your quiz in honors chemistry, if you say 107, I'm okay with that. So just go with 107 here. Now here's my bent. This is my 2 lone pair bent. And we had done this yesterday, and the bond angle is 104.5. And there's your marshmallow here, and I'll draw it in. There's your marshmallow here, and there's your marshmallow here. And so we're going to call this bent because when we name, we only name by the atoms. We don't use the lone pairs to name. And so this gives you that nice bent shape, and the bond angle again is 104.5. There on the quiz tomorrow, there is no single lone pair bent. It's only this kind. Okay, so no worries about that. I do want to kind of show you this. At this point, you can just stop listening to me, or you can do number 3 on the practice and go a little farther with it. So let me show you something. This looks really complicated and intimidating, right? Does this look kind of scary? No, no scariness. So let me kind of talk you through this. You can actually predict the molecular geometry on every single carbon. So watch me. This is very difficult, right? So what you have to do is you have to kind of put the rest of the molecule, you have to kind of white out in your mind. So if I ask you to predict the shape on this carbon, could you do it? Does it have any lone pairs? No, so it's what? Trigonal planar, right? Isn't that really hard? No. So let's go to the next one. And so you have to do this one carbon at a time. So what would be the shape on this carbon? This middle one. What would be the shape? Yeah, it's linear. Do you see how I'm doing that? Am I doing magic tricks right now? That ain't that hard. And so on this final carbon, right, and so it's trigonal pyramidal, or trigonal trigonal planar, sorry. And so that's not a big deal. This is kind of cool. I actually have some models. Did you wonder what the double bond actually looks like? Did you care? You want to see the things? And so, I told y'all yesterday carbon's black, right? So these little black spheres, that one there and that one there, that's a carbon. These are hydrogens. And this is a single bond. This one in the middle, that's called a sigma bond. See, this is a single bond. And then the second bond, the double bond, there's electrons that kind of are up here. This is a p orbital. And this is p orbital. And they kind of share. So this is really what, I'll draw it up here for you. This is not the same one. It has one extra carbon. Pretty cool. Boop. So if I'm drawing this that I have in my hand, here's a carbon, and this is this red one in my hand, this one right here, that single bond. The double bond is actually one electron shared in this p orbital and one shared in these. It's called hybridization. So that's a double bond. Okay, and then I have 4 hydrogens, 1, 2, 3, 4. You want to see what a triple bond looks like?
Yeah.
I showed you the things. That's it. I have to borrow this. And so, when you have a triple bond, you actually have, this is the similar. I'll draw this up here. So, how many hydrogens you'll have on this one?
2.
1, 2, okay? So, if you're not following me, that's okay. But there's my 2 carbons, and this middle bond, this red here, that's your single bond. This styrofoam up and down, these 2 parallel, that's my first hybridization of p orbitals. And then these p orbitals are shared. So, and this is called sp2 hybridization. This is like your S shared, and then 2 p orbitals. Isn't that neat?
Yeah.
There's so much more to this. I'll just leave it at that. I thought that was interesting. So there's your, that's really what it looks like, not this. But you can see the shape. And so if I showed you the shape on this carbon here, you can see, I'll pop these off. Black is carbon, here's your hydrogen, and look, it makes a little triangle. See? And these 2 are definitely linear, right? Because they're in a line. Yay! Okay. Okay. I'm missing a carbon in my picture, but I just wanted to tell you all the things.